Welcome and thank you for coming to this session on Session Manager. We're going to be covering securely managing your instances today and looking at the auditability and capabilities that come with attribute-based access control and federated identities. So we're going to go over a few things first. We're going to lay out some foundation on Session Manager initially, talk about some capabilities and some of the behavior, and then we'll dive into authentication models next, and then start to look at the different ways that you can use Session Manager to connect to those managed instances and cover those different methodologies. And then we'll follow that up by looking at the security and auditing capabilities that are built into Session Manager and how those integrate with other services like Cloudtrail to provide full auditability, even in a federated identity model where we're using attribute-based access control through tagging. All right, so first and foremost, we really just want to start to cover some of the basics of Session Manager and what it is, how it operates, and sort of what things it provides. At its most basic, Session Manager is really designed to provide you a capability that lets you quickly and securely access your cloud instances in AWS and third-party cloud providers, on-premise environments, and whether those be hardware servers or virtual machines. Session Manager is intrinsically cross-platform, so it supports things like Linux and Windows, as well as Mac OS. And it allows you to start those interactive sessions either with a browser-based one-click access model or through a CLI, either through the AWS CLI as well as through SSH. Additionally, with Session Manager comes a broad set of capabilities for things like granular access control, robust logging and auditing capabilities, port forwarding and tunneling, and then the execution of interactive commands as well as enhanced data encryption capabilities with KMS customer master keys. All of these functionalities are provided without the need to open inbound ports on the managed instance, or if you're on a managed instance in your on-prem environment, we don't have to poke holes through that boundary firewall to allow that inbound access. And there's no need to manage Bastion host or SSH keys on the host as well. So let's dig a little bit into how this all operates from the agent perspective. Most of the Amazon provided AMIs in the marketplace today, whether they be Amazon Linux, Windows, Ubuntu, all come with the Amazon Systems Manager agent included by default. And so if you launch instances with those, they'll automatically start the agent and attempt to register. The only other requirements for that instance to work is that it have outbound internet communications to port 443, or if you're in a VPC, you can also set up VPC endpoints as well to provide access to Systems Manager and Session Manager, even in a VPC where there's no outbound internet connectivity whatsoever. The only other thing that's required is that an EC2 instance have an IAM role that allows Session Manager API calls to succeed. And if it's a hybrid instance on your managed environment, what we'll do is set up a hybrid activation and then attach a role to that activation. So the same thing applies in that case. We still need to allow API calls to Session Manager. Once all those things are true, we have the agent installed and working, we have outbound communications to Systems Manager, and we have an IAM role that allows those API calls to succeed. All that happens is that agent initiates a handshake and does that via outbound connection. So the important thing to note about all Systems Manager agent-based services is that there are no inbound communications that are sent to the server. The managed instance itself initiates communications out to Systems Manager. This means that we're able to do all of these things like Session Manager without needing an inbound port to that server. And the first thing that agent is going to do is attach itself to Session Manager and establish a persistent control channel. Once that channel is created, it's a persistent WebSocket. That's where Systems Manager will start to pass messages down that channel and tell the agent to do something. So if there's work to be done, or in this case, a Session Manager session to instantiate, we'll send a message down that channel and tell the agent to open that session up. And so that's how that process works, and it's pretty much the same whether we're connecting over standard modalities like standard session manager session, or we're doing things like port forwarding or tunneling as well. So that's sort of the basics. And so what I want to do now is sort of get out of the PowerPoint presentation and start looking at this in a demo environment. And the first place we're going to start is to look at the authentication models within Session Manager. So we're going to pop over to the AWS console and start to have a look at all the different ways that Systems Manager and Session Manager itself can perform guest operating system authentication, and how we can integrate those with federated identity.
Okay, so we're going to take a look at Session Manager authentication, and we'll start with sort of the basic default configuration for Session Manager. And when Session Manager first starts up on an instance, it will try to create a local user called SSM-user. And in Linux, it's going to create an etc sudo configuration for that user. And on Windows, it's going to try to add that SSM user to the local administrators group. So in both cases, it's a privileged user, root equivalent or administrator equivalent privilege. And so if we hop into a session here on one of our instances, if we take a look at this Amazon Linux instance, for example, we can establish that session in the browser just like normal here. And if we take a look at our user context, we'll see that in fact we did log in as that SSM user. And if we try to switch to root, we can do that successfully, again, because that sudo or as config is in fact exactly as we would expect, all and no password challenge for any of those things. So it's an unrestricted sudo, right? If we wanted to reduce that privilege, we can do that in a number of different ways. We could come in here and modify the etc sudo rs config and actually put a challenge in here, or reduce that privilege down to whatever we wished. On a Windows server, we could take that SSM user out of the local administrators group, put them into a lower privileged group, say power users or something along those lines. And that would effectively restrict the permissions profile attached to that SSM user. So that's certainly one way to accomplish a reduction in those permissions. There are a lot of other ways for us to look at different user context and reducing that privilege profile. One of those capabilities within Session Manager is run as. And run as allows us to specify an alternate user context for Linux instances. So if I come into the preferences for Systems Manager and enable run as support for Linux instances, I'm given the opportunity to specify a different user. So this is a local operating system user other than SSM user that I want users to use instead. And now I could create this user on my instances, configure a lower privilege profile, and ensure that everyone sort of stops using the SSM user and reverts to this devops.support user instead, which again has a restricted privilege profile. So if I go save this setting here, that gives me an option to do that across the board for this account in this region. So any connection going forward that doesn't specify anything, any run as user different, will default to this user instead of SSM user. However, that will mean that all users get the same context again, just like we were with SSM user. Instead, this time it's lower privileged. One of the other capabilities of run as, though, is that we can actually do contextual based access. So I can actually come into IAM security profiles, roles, users, and actually tag those security principals and tell them what SSM user to actually use. In this case, I'm going to tag this role SSM session run as, and then actually specify a different user than we defaulted everybody else to, which in this case is DevOps Super. This user is going to be a privileged user and will behave very similar to the SSM user, but this shows that ability for us to specify different user contexts. And so anyone who assumes this role, say federated identity login, and they assume this role, when they create a session to a managed instance, it will now use this devops.super user. as opposed to the DevOps.support user, which was a low privilege. So if we come and take a look at that, we can see this in action. And what we'll do is just connect to that same instance like we did before in the browser. And we should see a different security context now. And so we should see when we check who we're running as, that we're now DevOps.super because I'm using that role and that role is tagged with this. And again, if I do a sudo su dash, I can become root again because I came in here and set up a configuration for that DevOps user, again, to mimic that SSM user. Now I could change that security profile and restrict this user to my heart's content. And what's great about this is this allows us to use that sort of role-based access model for SSM. So if I am happy to come in with a low privilege role in the morning doing my work, and connecting to sessions, I may come in with just enough privilege to read some log files, for example. But if later in the afternoon, I decide I need to escalate my privilege in this account and assume a different role in that account so that I can do more privileged work, then I can come in, SSH to that same box, or rather start a session manager session to that box. And now I'll assume a more privileged context, right? Because that role is tagged the right way. So this really sort of fits with that least privilege model as well. So we'll take a step back here and move into some of the different connection methods available to us in our next demo.
Okay, so now that we demoed out the different authentication mechanisms within Session Manager, the next area that I want to dive into is connection methods. And I want to start to explore the different ways that we can use Session Manager, whether that be through browser-based interactive shell sessions, if we look at the different CLI options, as well as our ability to start to do things like interactive commands, as well as SSH sessions, as well as port forwarding. So we'll hop over into the AWS console and start to take a look at all those different connection methods, and then we'll come back.
Okay, up until now, we've been making our connections to our managed instances from within the browser. But now we want to start looking at some of the other options available to us as we look at the Session Manager capabilities. So obviously, as we were doing before, we could establish a Session Manager session within the browser. We can also do the exact same thing here within our CLI. So if I want to establish a session across that native Session Manager channel, I can do that here. And what I'm going to do is just actually establish a session to this managed instance. You'll notice the MI prefix. This means it's an on-premise hybrid Red Hat Enterprise 8 Linux server. In this case, it happens to be EC2 that I'm spoofing this way. It's blocked from talking to Session Manager. It doesn't have an IAM profile, that sort of thing. But we've made it work as if it were an on-premise server. So this is showing our ability to connect to a on-premise Red Hat server that might be behind your corporate border firewall. We're not poking any holes. There is no port 22, there's no bashing, but we were able to still connect to that server from our laptop, right? From anywhere. As long as we have access to make calls to that AWS API, we can get connected. And again, as we look at this, we are using all of the intrinsic capabilities we looked at before. We're using run as. I came in as that DevOps.super user rather than the default SSM user. So all that capability still works just like normal from within the CLI. But where things get a little more interesting is in addition to that normal session, we can actually do things over top of that channel, and we can tunnel ports. We can put other protocols on top of that channel. Again, that agent is sitting there making that outbound connection to Systems Manager, waiting for work to be done. And so this allows us to do things like tunnel protocols over top of that channel and have the agent actually initiate that connection for us through Session Manager without needing an inbound port. So in this case, this allows me to do things like SSH over top of that session manager channel while still not needing to have port 22 open on the firewall or have a bastion host in place. Now, one of the things that I've done here on my laptop is set up a SSH config helper that looks for any host that starts with I- or mi- and just executes this SSM command for me as a proxy command. That way we establish a SSH tunnel over top of Session Manager automatically. So if I go and execute a verbose SSH connection to this particular Red Hat Enterprise Linux server, what we'll see is that it in fact does exactly what we expected it to. If we look at the top of this connection here, we'll see that it did in fact execute our proxy command as we expected, and we're now authenticated as the EC2 user using an SSH key pair, not as that SSM user or that DevOps.super user, because this is just a standard SSH login in this case. SSH functionality works over top of this like normal, so you can do things like SCP to copy files over top of this as well. So it's a pretty powerful context, and again, we can do all these things without actually needing to poke a hole in our border firewall, to have a bastion host up in our VPC. We don't have to have port 22 in the security group at all. So super powerful way to leverage SSH over top of that. Taking it a step further, we can actually redirect arbitrary ports as well. It doesn't just have to be port 22. So one of the great things here is like if we have Windows servers in our environment and we don't want to have a bastion host, but we still need RDP to these, we can actually do the exact same thing over Session Manager, but in this case, start a port forwarding session and give it some information. So just like we would with an SSH tunnel, for example, we're going to specify the name of the host, in this case, a Windows server. This server is an EC2 instance. It's in a private subnet. It has a security group with no inbound ports allowed at all. So 3389 is not permitted, but we're still going to be able to redirect 3389 and actually get connected here. And in this case, I'm redirecting the local 3389 to my laptop's 3389, and we'll make that connection happen. And we'll see that it's sitting here waiting. And if I come over to my remote desktop client and look here, you can see that we're actually connecting to local hosts. And if I just double click in here, we can see that it's now accepted that connection for us over top of that session. And if I just come in here and place our Windows administrator password, we will see it actually establish that connection. And just like that, we're now connected to the Windows server over top of that session manager session. So very powerful context. We can use this thing for everything from MySQL Workbench to attaching to Apache Tomcat instance that's in a private subnet. All sorts of capabilities there. And last but not least is another option to execute interactive shell commands. And this is a very powerful way for us to not just give a user access to an instance and allow them to freehand and sort of run commands at will, or if a support engineer needs to, for example, read a log file, we don't have to give them unfettered access to log into the server and sort of peruse around and execute commands. We can say, I want you to be able to tail a log file, and all you need to do is give me the path of the log file, and I can restrict you to just tail-f, for example, and I can also require that whatever path you sent me is actually a .log file. I'm not going to let you just read, .confs or look at sensitive configurations and things like that. So if we execute this command, for example, we're going to run a document that I created which does just that, which is restricting this user to just tail-f, and we're going to look at the Amazon SSM agent log. And you can see we established our session, we've tailed the log, but we're still connected and it's interactive, right? So all we're doing is sitting here running tail-f over top of that session. And if we go and generate some work against that instance, for example, we'll watch that log above us actually start to scroll past because it's an active interactive shell. And so this is a great way for us to do things like tail logs, to execute commands that require us to provide some set of input and wait for that command to complete, reset passwords, that sort of thing. And so that's a great segue for us to start to look at, okay, if we're going to do something interactive, for example, resetting a password, we're going to be sending potentially sensitive information like a password over that session. So we want to look at our options to not only understand what Session Manager does from a normal security perspective, but ways that we can even enhance that further with other services like AWS KMS, and look at how we can add an extra layer of encryption there so that we can actually pass sensitive credentials over that channel.
All right, so now that we've looked at the different connection methods, the next thing we want to dive into is the security and auditing capabilities within Session Manager. So we'll go back into the AWS console and we'll start to take a look at the different security mechanisms that are in place and the way that we secure communications and your options to enhance that encryption. And then we'll also look at the auditing trails that are created and our ability to log session instances and session commands and outputs as well. So we'll look at all the different ways that we can trace those connections and look at all of that auditing trail in conjunction with the way that Cloudtrail will integrate with those as well. So we'll hop over in the console and then we'll come back.
Okay, so when we left off earlier, we were executing different connection types over Session Manager, and now we want to look at the security and auditability features within Session Manager. And so those sessions that we were running before are still open, so this is a good opportunity to go look at the auditability and traceability features within Session Manager. As we can see, both of those sessions are showing up as active right now. One is that interactive shell document that we ran, and one is a normal session just connected to that instance. As an administrator, I can see these, and if I want, I can actually terminate that session centrally, and now that session is no longer open, and the person who had that open in their terminal will see it terminated and closed. Another great thing is that we actually have historical context for these sessions as well. So I can go back and see who connected to what and what type of session they established. And for all of the session types that support logging, for example, if I'm not tunneling SSH, we can look at the outputs of what they actually executed as well. So not only can I see when they connected and when they disconnected and what they were doing, I can actually look at the logs from that session and see everything that was typed, what the responses were, what they viewed, what they did, that sort of thing, right? So in this case, this person literally just connected to this instance and executed no commands as devops.super, but we can see that they got a bash prompt and then sort of did nothing in that session. But this is a great way for us to be able to go in there and have a look at what a person actually did, and if we have to look at an incident after the fact, we can review what commands were executed, what that result was. And the great thing is, because we capture things like standard error, standard out, standard in, any sort of just typing or keystrokes, if I type in a command and I mess up and I backspace that, I'll see the messed up strokes as well as the backspace key. I see all of that input no matter what, even though that they didn't hit the enter key, I see that keystroke, right? So it gives you a lot of great context to look at. In addition, if we go back into Session Manager preferences where we were before, we'll see that we, as an administrator, can control a lot of different settings here, like idle session timeouts, so that people don't leave sessions open for longer than whatever period we want. In this case, 45 minutes. We can control that logging, like I mentioned. I can make sure that all sessions log all of their data to a encrypted CloudWatch log stream. And make sure it's encrypted, right? So that there's any sensitive data in those logs that they're not exposed. I can do the same thing, make those go to an S3 bucket as well and encrypt that data as well. And another great thing when we're talking about data encryption is the ability to use KMS on top of the existing encryption. So Session Manager sessions, by default, all communications between that agent and Systems Manager are encrypted with a TLS 1.2 session. What we can also do is add a customer master key in here and say, in addition to that TLS 1.2, I want you to use that CMK to symmetrically encrypt that session within that TLS 1.2 session. So now we have two layers of encryption, one that's controlled by you, the customer, And in that case, that gives you an extra layer of protection if you're going to do potentially sensitive operations, say, for example, passing a credential or password over an interactive shell command to reset a password for something. So just a very good look at some of the intrinsic security capabilities and that auditability that we can do on top of Session Manager. So we're going to move into the attribute-based access control from here.
All right, so now that we looked at the security and auditing capabilities within Session Manager, the next area that we want to dive into is attribute-based access control. And before we get back into a demo, we're going to dive a little bit into what ABAC actually is and why we might want to consider using that and the ways that we might integrate it. So the first thing to consider about attribute-based access control is what is it that we're talking about when we mention attributes. So in this context, attributes are really nothing more than resource-based tags attached to some resource or an identity principle. So in this case, if we're talking about an IAM security principle like a role or a user, those would be tags attached to that user. If we're talking about, say, an EC2 instance, we might have some tags attached to it that describe some attributes. And really where this starts to open up a little bit is the ability for identity providers like federated identity providers like Okta, for example. What we can do is attach those attributes to the underlying security principle in the identity provider. So for example, if I'm Dave and my user ID is Dave, I might have some other attributes that describe my role in the company. For example, what team I'm assigned to or projects that I'm working on. And then what we can do with that is, because the identity provider will actually send those attributes to AWS during the SAML authentication process, we can now have those available to us when we're making decisions about access control within IAM. And so this allows us to dynamically provide access to resources that match those attributes without sort of having to update that policy every single time that something changes or we launch new resource types or something like that, right? So we don't have to get into that sort of situation where we're explicitly describing everything in the policy. And so, yeah, that's sort of the benefits, right? Is that the ability for these permissions to scale with that innovation, right? So the faster we go as we're launching new resources or new resource types that we didn't have before in that policy, now suddenly we can start to just automatically get access to those, because if they're assigned to the correct attributes, for example, if I'm in the green project and those resources have a project attribute that's marked as green, that policy will automatically allow me to access those without anybody having to go in and actually provision that access, right? And it still allows us to have granular, fine-grained control over that permission without requiring us to update that permission every time a new user or new resources come online, right? And it still gives us the ability to, with that SAML authentication that I discussed earlier, to audit those attributes and see those as part of the Cloudtrail, right? So when we see that assertion or that SAML role assumption happen, those attributes will also be visible to us in the Cloudtrail event as well. So it's good from a perspective of auditing as well. And one of the great things here is that, as I mentioned before, in this model, those session tags that are passed to us makes the identity provider the source of truth, right? So those user attributes come from whatever our underlying identity source is, whether that's Active Directory or Okta users directly inside the system. And those are passed to us for each federated session, whether that's a CLI or console access. As I mentioned before, those permissions are automatically going to apply based on attribute changes. So if I suddenly move from the green project to the blue project and somebody updates my user and AD, my permissions change dynamically. The next time I log in, I'm going to only have access to the resources that match my attributes, and nobody had to go in and change that permission for me inside AWS. And there's a lot of different providers out there today from an identity perspective that are supporting these session tags and this ability to do attribute-based access control. And so what we're going to do next is go into a demo of what that attribute-based access control looks like in principle. And we're going to do that by looking at an Okta federation and set up the IDP for attribute-based access control and show you what that would look like in practice. So we'll hop over to the AWS console, look at that, and then we'll be back.
All right, so as we were talking about with attribute-based access control, one of the great things that we can do with ABAC is that as resources come and go in our environment, we can set a policy that grants access based on attributes rather than having to go into those policies and explicitly update them every time people change jobs or resources change or we add new things in the environment. With the ability to pass those session tags through from the IDP, we can suddenly start to use attributes that come from that identity provider and make dynamic decisions about what resources they have access to. So for example, I have an Okta IDP set up here, and what I'm doing is passing custom attributes through to AWS. Things like what team is the user assigned to, what project is the user assigned to, and I'm passing those transitive tag keys together as team and project so that I can make some decisions based on that easily. And I'm also passing things like what's the user's login, and in this case I've got that configured as my email address. And so that's what's going to be passed to us during that SAML authentication. And what's great is that if we come into IAM, now we can start to craft policies around those attributes. And we'll see an example of how this makes our life a little bit easier here. So in this case, I might want to allow users to start a session manager session, but they should only be allowed to do that against resources that are applicable to the project they're on at the time, right? So they shouldn't be allowed to establish connections to other people's instances. So rather than have to go and craft a policy for each project, like Project Blue can access resources that look like this, and so on and so forth, or as resources change, make adjustments to the policy, I can come in here dynamically and just say that any user is allowed to access session manager sessions and start a session if the project tag on that managed instance matches the project tag assigned to them from Okta, right? And so suddenly if I'm on Project Blue today and then 2 days later I get assigned to Project Green, automatically next time I log in, I've got access to Project Green resources. I lose my access to Project Blue, and nobody had to come in here and do anything about it, adjust my policy or anything of that nature, right? That was all dynamic. Same thing applies for that SAML attribute login that I'm passing in this case, right? Passing that as that principal tag allows me to do things like allow this policy to say, whoever is assuming this role can terminate session manager sessions, but only if it matches the login that they have. So that would mean that I can only terminate sessions I created and not terminate anyone else's. So this is just like a basic example of how we can use SAML attributes and session tags to implement attribute-based access control in Systems Manager. And it's a very powerful context that should keep you away from that sort of management overhead, but still give you the ability to do fine-grained access control and least privilege models. One of the other things I want to point out about this is that Cloudtrail makes your life very easy too from an auditability perspective, because attributes can change over time, but Cloudtrail will keep a record of things like assuming the role with SAML, for example. In this case, we can see that Cloudtrail is actually recording the principal tags and transitive tag keys that I passed from Okta, so that at any point in time, I can go back and say, okay, this user assumed the role. What project were they assigned to, on this date? And 6 weeks later, that project may be different, but we can always get a snapshot in time of what the context was for that user when they did this action. So this is just an example of the capabilities that are both intrinsic to AWS as well as our IDP partners that allow us to do really cool things in this attribute-based access control space.
All right, so that's it for us today. So I want to thank you for attending the session. And as always, if you have any questions, always feel free to reach out to your account manager. My contact information is at the end of the slide as well. So if you guys have any questions or anything like that, feel free to reach out. And we look forward to talking to you and looking forward to what you can do with Session Manager. Thank you.